Hi, everyone. Welcome to OT 699, Building Technologies that Promote Health and Occupational Engagement. We are really excited to have you here. We're going to go over in this short video kind of the course objectives and the course structure. Then we'll have some videos where we introduce ourselves. Actually, let me just go to that. We'll do the course overview now in this lecture. Then we'll introduce ourselves, and we are looking forward to meeting each of you in class, and you'll be able to introduce yourself then. And then we'll have a lecture that's on the basics of computer programming. So we're really just going to dive right into it. Okay, so for course objectives, our goal and our hope is really that by the end of this course, you'll be able to identify, describe, and develop innovations that promote health and increased occupational engagement. And I've put in parentheses here with collaboration because we don't really expect that by the end of this course you can use all these technologies independently, because honestly it takes years to be proficient in any one given technology. But the goal is for you to get this high-level overview so that you know what the technologies are, and you know kind of if you wanted to make something or innovate or create something new, who you would need to collaborate with. A second goal is that we would love by the end of this course for you to be able to know how to create a business development plan for a technology that meets a clinical need, and also to be able to identify appropriate software and hardware skills that you would need to be able to make that concept implemented or essentially come to life. And then lastly, we're going to have you design actually an initial prototype of a concept that you might have. So we'll talk a little bit more about that as well. So why did we make this course? I am really excited about this course. It's something that's been a passion, and I've been thinking about how we would do this for a few years now, I think. But there's a lot of reasons. Just a few are that, first of all, innovation is kind of this buzzword that we hear all the time. It's really a key component of both the overall USC strategic plan as well as the Chan Division strategic plan. I think it's because if we're not creating things that are new that solve problems that are otherwise going unsolved, then what are we doing? So it's really just, in my mind, innovation is just this process of problem solving by putting together new ideas. In addition, technology is also a word that's thrown around all the time. It is a field that's constantly evolving at a super rapid pace. So if you just think back 5 years ago or 10 years ago, I was, well, I'm gonna date myself now, but I think I was in the 5th grade when AOL came out with chat initially, or maybe the 1st grade. I don't actually remember. Anyways, just to think that like back in the day, I used an old MS-DOS computer, which most of you probably have never even seen before. And now, just like a few decades later, we have tiny computers in our back pockets and on our watches even. It's pretty incredible. And I think especially as we move forward, it's critical for our graduates to be equipped to use all possible tools, including different types of technology, to solve healthcare challenges that you might encounter, no matter what area of practice you decide to go into. And then we also, like I said, these are really common buzzwords, so innovation and tech or innovative tech. But I think a lot of people don't know what that actually means. So here in this class, we want to give you hands-on examples so you can kind of have a more concrete idea from your own knowledge and your own playing around with these things, what they mean. And then lastly, I honestly think that playing around with technology is just a lot of fun. It's kind of learning. For many of you, this will maybe be learning these things for the first time or introducing you to new concepts. And that to me is really exciting. So this is what I do for fun. If I had more free time, I would make deep dives in some of these areas. So we're hopeful that you'll really think about this class as your tech sandbox or playground or whatever the term is that they use now. But like I said, it's really going to give you a high-level overview so that later on, if you have a specific problem, let's say you're in the clinic and you're working in pediatrics and you think, oh, I wish we had like a game for the clients that I have that have cerebral palsy to help them reach a little bit further or to give them feedback about their muscle tone. you could actually start to think about how you might be able to do that. You could think back to this class and some of the different tech that you played with and have an idea of how you could actually get started to create a customized solution for them. Like I said, it's also a chance for you to learn and play around with different types of technologies. And the last thing is, this is in a lot of ways a sandbox for Dr. Lane and myself as well, because we've never done this class before. So these are all things that we've been teaching people in my lab, especially when new people join, we teach them little bits and pieces of things, but we've never done it through a formal structure like this class. So we are really excited. We will be playing around with different techniques and working with you to adapt the class for your needs as we figure out kind of what works best. Okay, in terms of course expectations, these are really, I think, our goals for you and also your goals, maybe for us. I think based on the lectures alone in this 2-unit course, you are not likely to become independent or proficient with any of these technologies. So I don't think that by the end of this course, you would be able to say, I'm a programmer now, or I'm a game developer or an app developer. Really, the goal is just that we want to show you what each one of these technologies is and give you a flavor of it by providing a really structured hands-on tutorial for each thing. And then that way, if you wanted to become proficient, let's say you thought to yourself, wow, of all the units that we went through, the app development was the one that I think is the most relevant, then you could actually focus and take time on your own after the course or during the course to become proficient and develop proficiency in that area. So like I said, the reason, one of the reasons Dr. Lane and I both teach this class is because Dr. Lane has skills that I don't and vice versa. And so nobody's expected to kind of be a tech guru and have massive proficiency in all areas, just because it can take months, weeks, years even to really know what you're doing. So the idea is just that you can identify a clinical need, identify what tools you know could be useful, and then either dive into it further on your own or collaborate with somebody who is already proficient and be able to have great collaborations and conversations with them. All right, so this information is all in your syllabus, but I thought I would present it this way for you just so we can go through it. We've really divided the course into 3 different kind of segments or units. The first 4 weeks, we're going to be talking about software. So we'll do 2 weeks on computer programming basics. Again, this is assuming you have 0 knowledge with computer programming. If you do have knowledge, this might go a little bit slow for you, and I think that's okay. But it's designed for people who have never been exposed to programming, really. Then we'll have 1 unit on basic app development, and then finally we'll have 1 on gamification and game engines. And in these units, really each lesson builds on the next to some degree. There is some independence between them because we are talking about different technologies, but we've tried to structure it so that we're teaching you what you need so that it builds up towards the end of the class. The second unit is on hardware. So those are like physical technologies and applications. And this will be more on prototyping. You'll get to work with an Arduino, hopefully, which is basically a very tiny, cheap computer that you can program to do specific tasks. You'll also learn a little bit about sensors and in the process about electronic device data acquisition and design. And then there will be 1 class where you'll work on putting together the hardware that you've been working with the software that we'll talk about in these first 4 weeks. And then the last one will be on 3D printing. So in an ideal world, we would be able to bring you in to actually see our 3D printer. But we're trying to do the next best thing, which is record somebody from my lab, Mr. Octavio Marin Pardo, who is a biomedical engineering PhD student in my lab. And he's going to record his whole process of 3D printing some of the objects and devices that he uses for some of our projects. So you will get a behind the scenes peek at all the steps that go into this. And then finally, in the last part of the class, we'll be talking about implementation. So that's really taking all of these tools that we're giving you and trying to pull them together for solving a clinical need. So the first week of that, we'll be looking at intellectual property, licensing, and just identifying a clinical need. The second week, we'll be looking at innovation, so like market analysis, value propositions and putting together a business plan. And then the third week will be creating your own prototype design and market plan and really putting together a project pitch, so that if you were to create a device that met a clinical need and a new innovation, how would you market this and make it become something real? And then the final project / capstone project is going to be a presentation where you're going to do a pitch of your prototype design and your business plan. So I think as we go through this, I think I really wanted to lay this out for you because in the first 8 weeks, you're really just learning skills. But the whole time, I'm hopeful that you will be thinking about different clinical needs that you've encountered already, or that you may be encountering through your fieldworks and things, so that by the time we get to the end, you have a pretty clear idea of how you'd like to use some of these technologies to create a new solution. In terms of the weekly schedule, this is a 2-unit course, and the course is actually only 11 weeks long, so it's a slightly abridged schedule. That means each week we will meet for 2 hours and 20 minutes. The first hour and 20 minutes is mostly going to be asynchronous, so these are going to be a mixture, depending on the week, of, well, they'll always be pre-recorded, so you're expected to watch them on your own time and preferably before we meet in person, but there'll be a mixture of lecture and follow-along lab work. So this can be done at your own pace. You can, if this is boring, you can watch it at double speed, but the goal is for you to kind of have all this information so that when we meet in person or synchronously online, we'll be able to do hands-on questions, troubleshooting, and a lot of discussion and really just hit the ground running. So like I said, the 1 hour synchronous time is really hands-on lab and troubleshooting. So it's time to go over the material, the labs that you might have done on your own and talk about any challenges that you might have encountered, etc. Each of the synchronous classes will start with a 4-question quiz on the material from that week. So just kind of make sure that you checking in, make sure you understood what you watched, and if not, it kind of gives us a gauge of where we might need to fill in a little bit more. This also goes into the grading. So our ultimate hope is that you just love this material and love this course so much that the grades aren't really that big of a deal. But I know grades are important and they matter. So the way that we broke it down so that it is mostly experiential is that 55% of your grade is from these weekly quizzes or assignments and participation. So like I said, every week you'll have a quiz and that's 4 points. And then there will also be 1 point for participation. And we expect, of course, to hopefully have active engagement, active discussion, and cameras on, and people being attentive and really being there. I think by now we all understand how Zoom works and how to have the most beneficial conversations. The other 45% of your grade will be from your final project. So again, that's something that you'll be building up to throughout the whole course. But this will be a capstone project presentation, and we have a whole rubric that we'll go over later for this presentation that will kind of cover, like how innovative is your idea, the market need and market analysis and business design, and then also, of course, the prototype design. So how much of the technologies that we covered were you able to integrate, and do you really seem to understand what the role of those technologies is in solving the problem that you've chosen? So it's important for me to note now that you're not going to necessarily create a final prototype. So like if you said, I want to create this whole wearable vest with sensors and an integrated app and game and things like that, that's a lot of work. So you're probably not going to be able to make that in this class. But you should be able to design what steps the prototype will require, identify all the needed technologies, hardware and software, and put together a plan and maybe a mock-up of what it would look like. In terms of housekeeping, so our final presentation will be on Friday, April 9th. We'll send out a doodle to determine the final time for that and talk about that more as it gets closer, but I just wanted to give you a heads up on that. That's the only one where we won't, otherwise all of our classes are Thursdays from 2 to 3. And then for office hours, typically either myself or Dr. Lane will be available right after our live session. So the live session goes Thursdays 2 to 3, and then from 3 to 4, either myself or Dr. Lane, whoever was kind of leading the lecture for that week, should be available. You can also email us, or please email us actually, if you plan to attend office hours, just so that we have a good idea of how much time we can spend with each person. And then if you need times outside of that, you can also let us know. Okay, so our goal is that by the end of this, you should be equipped to think critically about clinical problems and needs and how to develop an innovative solution using technology or not. I mean, I think also part of this is understanding the limits of technology and when it may not be useful. So we are not tech advocates per se. I think a lot of times the best solution is a low tech solution, because it tends to be more robust and work all the time. But there are times when technology can fill a gap that nothing else can. And I think it's good for you to understand when that is and when it isn't. Another point is that you would also be, by taking this class, well positioned to enter the Chan Moshiyeti Innovation Award competition. This is an annual competition that we'll talk about more later on. But that competition happens April 30th. So in part, we're finishing early also to give you some time if you wanted to enter whatever your innovation was for that competition. You'll have time to be able to kind of brush it up and put together the final touches before then. And then finally, I just hope that you have a lot of fun tinkering with new technologies and learning a lot of new skills. Dr. Lane and I, like I said, are super thrilled. We don't think there's another course that's quite like this that covers all these different technologies in one class. And that gives like a pretty like hands-on, but still beginner access to them. So hopefully you'll have fun. Feel free to email us at any time if you have any questions or comments or feedback, and we'll also be checking in with you as we go too. All right, so after this, you can watch the video introductions that we have of ourselves just so that you know who we are. And then I'll have another lecture for this class about the basics of computer programming. Hi, everyone. Welcome to the very first ever session of OT 699, Building Technologies that Promote Health and Occupational Engagement. I'm one of your instructors, Dr. Suk Lee Liu, and you will also meet my co-instructor, Dr. Chris Lane. These videos are just really brief introductions, so you'll get to know us a little bit before we dive into the lecture. And then when we have our live synchronous session later this week, we'll get to do more introductions and get to talk a little bit more. So I'm really looking forward to meeting all of you. Just briefly, so that you know, my background actually is not in technology or programming or computer science or engineering or anything like that. I actually have my bachelor's degree in English and sports medicine. If you ask what do you do with that type of degree, I didn't know myself. So my senior year of college, I took a career test to figure out what I was supposed to do with that type of background. And it suggested that I become either a farmer or an occupational therapist. I, of course, knew what farmers were and do, and it was exciting. It's still kind of on my list of future occupations. But I had never heard of occupational therapy. And so I looked into it. I started shadowing a pediatric occupational therapist that was in my local area. And I loved it. I applied to OT school and I actually did my master's degree here at USC in occupational therapy. The very first summer of OT school, as was probably the case for many of you, I had a class in neuroscience. And that was my very first exposure to neuroscience and understanding that basically the brain controls all of our behaviors, and damage to very specific parts of the brain can lead to really specific behavioral changes. And I found all of that really fascinating. So I actually started doing research while I was in the master's program. I stayed at USC to do my PhD in occupational science. I worked with Dr. Lisa Aziz Zadeh, and I learned a lot about brain imaging, specifically MRI and fMRI. And that was kind of when I first started to get my hands wet with programming, because you need to use computer programming to analyze brain imaging data and to set up like stimuli that you're present in the experiments. And it was a rough road trying to learn those things on my own, especially with no sort of like technical background. And that, I think, has led, though, into this really lifelong love of technology and trying to understand how we can use all these different tools to support our clients when we work with them in clinical settings and just to solve daily problems that we might encounter. I think programming is really fun. It's like a second language or another foreign language, which I'll talk about more. And I really love all aspects of kind of tinkering. So Dr. Lane and I are really excited to bring you this class just because I think it's meant for people who, like me, back when I started, had absolutely no background, no familiarity with any of this, had never typed a single line of code or done anything along those lines. It's meant just to teach you about what these things look like, get you interested in them, hopefully, and give you a high-level overview of what different technologies are that you could potentially use in the future. So that's my background and introduction. Dr. Lane is also going to give an introduction to himself. And then I will go over the course overview and we'll have a separate lecture for our very first day of programming. Okay, nice. I look forward to meeting you all.
Hi, my name is Chris Lane. I'm going to be co-teaching this course with Dr. Liu. I'm very excited to be part of it. I wish I had had a course like this while I was in graduate school. I think it'll be fun. Many of the things that you're going to be learning are actually what people do for a hobby. It's kind of fun to be able to create new software, create new technology, take a vision that's just an idea in your head and make it into a physical reality. All of these kinds of things usually take an accumulation of skills that you get over 10 years of trial and error and trying to find tutorials online. And we're trying to put it all together in one place at one time. I think it'll be fun. As far as my background, it's a little all over the place. My undergraduate degree is in biomedical engineering from Rutgers University in New Jersey. And at the end of that process, I wanted to go more into medical research rather than going straight into industry. So I got a PhD in physiological sciences at the University of Arizona in Tucson. That was mainly topics of movement control and neuroscience, a lot of upper airway, breathing, the respiratory system, things like that. And that set me up for a postdoc in what's called neurorehabilitation engineering. So basically, this is some kind of combination of what you might have heard of as biofeedback, but now directed more towards changing the nervous system for a rehabilitation purpose, kind of a combination of science and engineering, mainly focused on neuroscience and movement control. And then when I came back to the United States, it was to USC here in the biokinesiology and physical therapy division. And about that time, I transitioned into being a research professor and started teaching courses in things like computer programming for researchers, especially those who are collecting data from humans, and especially biosignals, things like EEG and EMG, things like that. And I've been in lab settings working with essentially hacking a lot of the equipment that we end up using for research. I've also started a company, Adventure Biofeedback, which is looking at providing some telehealth software for pediatric speech therapy. And that's sort of outside of my USC obligations. This is more of a weekend and evening thing. But that gave me some insight into how med tech is developed from the idea incubation aspect, hackathons and local competitions, things like that, all the way up through the entrepreneurship side, where you've taken an idea and people seem to like it, but now you need money, now you need to attract investors, incorporate, deal with intellectual property. So I have a little bit of experience in that, and you'll be learning a little bit about it as well in this course. So it's going to be a little bit of a hodgepodge of many different things, but it'll be really useful and hopefully really fun. I'll see you all in class or in the synchronous Zoom session.
Hi, everyone. All right, we're going to jump straight into the basics of computer programming first part. And this is also the start of our first unit on software. So the objectives for this week's session is that by the end of this, you should be able to understand maybe a few reasons why computer programming is useful, describe a few common principles that are used in computer programming. You will also be able to install Anaconda, which is just one of thousands of programming environments. You will open a tool called Jupyter Notebook, and you will write your very first lines of code in Python. So the first distinction that I wanted to make clear is what's the difference between software and hardware. This may be obvious to some people, but may not be. So when we talk about software, we're really referring to files. So these are computer programs, code, commands to the computer, things like that. In contrast, hardware are really the physical components of a computer or associated machine parts like sensors, robots, things that you can touch with your hands. So that's kind of the distinction. We are definitely going to learn to use them together, and they are very rarely, well, actually, I guess I would say that they are very rarely used separately. There's a lot more instances where software is independent of hardware. You rarely have hardware without software. But that said, even when you're running software, like you're running an app or you're running Microsoft Word or even PowerPoint or Zoom, those are all softwares. You still need some hardware to interface with it, like a keyboard and a monitor and a microphone and things like that. So we're going to start with the software, so we just understand how to talk to computers first, and then we'll move on to the hardware. So why computer programming? I think if you want to work with technology, you need to learn how to talk to the technology. And so you need to essentially learn how to tell it what you want it to do in terms that it can understand. I always like to talk about computer programming as another language, similar to a foreign language. So English, Spanish, French, each of them has similar concepts, but they may have different words, different vocabulary, and also different syntaxes. And so similarly for computers, they have their own languages and syntaxes, and there are a ton of computer programming languages as well. And we'll talk about that in a second. And so programming, just a few of the things it'll let you do is create web pages, apps, you can program robots, you can program devices. Hopefully, like we talked about in this class, you will be able to program a small computer and a sensor to become part of an app or a game. But it basically is the basis for understanding how all of this works. And while we don't necessarily think that you'll become a super fluent computer programmer, it is really important for everyone to understand how programming works, because it helps you to know what the limitations are of what computers can actually do. Okay, so we're going to have just a quick little bit about binary here. Binary, how do I say this? Okay, so human readable inputs like letters, numbers, symbols, all of these things that you see on my screen here have to be translated for the computer. So we call these human readable because it's things that you and I can look at and understand easily. Like I can read all of these words here. But how does a computer interpret each of these things? Well, it interprets it in binary, which is essentially a machine language that just has two states. So it converts every single letter and every single character that you see here and these colors and everything into a very long series of zeros and ones, where 0 is essentially off and 1 is on, or 0 is a down switch and 1 is an up switch. So we're going to take a break here and watch this video. And then I will have you, you can try it yourself with this online tool. So you can type in text. I suggest you just type in like one letter at a time, but you could convert it into binary so that you can see what the computer sees.
It's a common theme throughout the modern world that everything in a computer's brain comes down to ones and zeros. You've most likely heard that this code of ones and zeros is what's referred to as binary. And while almost everybody knows that this is somehow related to what computers do, very few of us seem to understand what binary is or why computers use it. If you want to know, then this video is for you, because it's actually a very simple concept and still quite fascinating. Before we get to computers, let's talk about what binary itself is, as it existed long before computers did. Binary is nothing more than a system of counting. To understand how it works, let's look at two other systems of counting, tally marks and the glorious base 10 positional that we all know and love today. Tally marks are the simplest counting system imaginable. However many things you have, you put down that many marks, easy as pie, but not very efficient. Meanwhile, base 10 positional, which is what we use today, uses a different symbol to represent different amounts of things. With the numbers 0 through 9, we can recognize that each symbol indicates a different amount of things. If we need to represent something higher than 9, we add a digit to the left, roll this first digit back to 0, and start over. This system is very efficient compared to tally marks because each digit we add exponentially increases the amount of things we can represent. Because in this system we add a new digit every 10 things, each digit represents an increasing power of 10. This is the number of ones we have, the number of tens, the number of hundreds, the number of thousands, and so on. Now this is probably something you already know, but it's very important to keep it in mind when we talk about binary. Now binary works the exact same way as base 10 positional, but instead of each digit going from 0 to 9, it goes from 0 to 1. Counting upwards in binary sounds like this: 0, 1, 10, 11, 100, 101, 110, 111, and 1000. Because each digit of binary has only 2 values and not 10, each additional digit represents an increasing power of 2 rather than an increasing power of 10. So this is the number of ones we have, the number of 2s, 4s, 8s, 16s, 32s, 64s, 128s, and so on. Not nearly as efficient as base 10, but exponentially more efficient than tally marks. Literally. So now that we know how binary works, let's talk about computers. Why did the first computer creators, as wise and intelligent as they are, waste their time with such an ineffective system of counting? Well, it's because of a physical limitation on how computers work. Everything a computer does comes down to what's known as microtransistors. Simple, tiny, eensy-beensy little switches that can either be on or off and can be flipped on or off with a very weak electrical charge. The first goal was to get computers to count. And to get them to count by using these switches, we could use the tally system, meaning the number of on switches equals the number of things we have, or we could use the much more efficient system of binary, where each switch represents a digit of binary. 8 transistors using the tally system could represent a number as large as 8 by turning all of them on. With binary, we can represent a number as high as 255. An on switch means a 1, and an off switch means a 0. Now is a good time to mention that a single transistor is what's known as a bit, which stands for binary digit. A byte is 8 of these bits in a row, which means any number between 0 and 255. So if binary is just a system of counting, what do people mean when they explain how to spell things in binary? Well, what they really mean is how to spell things with ASCII. The American Standard Code for Information Interchange is a way to convert a computer's data, which can only be in numbers, and turn it into letters for humans to have an easier time to work with. ASCII simply assigns a character to each value represented by a byte of binary. Now because a byte has 8 digits of binary to work with, and 8 digits of binary can represent up to 255 values, ASCII had 255 letters and symbols to choose from, more than enough for the entire alphabet, punctuation marks, and other symbols. For example, the corresponding ASCII number for an uppercase A is 65. Now 65 in base 10 is equal to 1,000,001 in binary. So whenever you type in an uppercase A in a word program, a coding program, or a scripting program or whatever, somewhere there's a little tiny row of 8 transistors arranged in the pattern of off, on, off, 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 on, which represents 0, 1, 0, 0, 0, 0, 0, 1 in binary, which is interpreted as 65 in base 10, which is converted by ASCII into an uppercase A. You're likely starting to get a feel for the staggering amount of transistors required to write something as simple as a Facebook status, let alone all the different coding that your computer has to do to make the screen light up, play games, calculate massive values, and so on. Well, long before we got to the point where your phone can play 3-dimensional games, it became clear that numbers as high as 255 just weren't going to cut it. Regardless of how many bytes we had, and it was a lot, even adding 4 fully active bytes together could only get a number as high as 1020. To solve this problem, new computers were designed to recognize 2 bytes as one single number. So now instead of referencing one line of 8 transistors, computers could reference 2 lines, giving 16 digits worth of binary. This was a huge help because it increased the amount of representable numbers exponentially from 255 up to 65,535. When you hear people talking about the difference between 8-bit and 16-bit, this is more or less it. Now that doesn't mean that a 16-bit system is exponentially that much more powerful, because your program isn't always going to be utilizing all of these numbers in each byte that it represents. It just has the option to, which opens up lots of doors. Well, this could go on for ages and ages, but I want to end this particular video right here so as not to be overwhelming.
Okay, so hopefully that video was helpful for you and gave you some ideas about how binary works. Like I said, with computer programming, I mean, this could be a very deep dive. We can go really far down the rabbit hole, and you could spend like a whole year just learning about the history of computers and how all of this came about, etc. It's not very functional knowledge though, so we'll just skip it. What I would really like you to understand is that because the computer interprets everything that we type to it in binary, it really matters that we are precise with what we type. So what I'm showing here are some examples of binary, like a capital A is interpreted by this sequence of zeros and ones, but a lowercase a has a different sequence of zeros and ones. So there's an extra one here. If you wanted to write just the word hi with an exclamation point, that's 3 characters, and each character, this is capital H, this is lowercase I, and this is exclamation point. A space has a different binary it's not like it's not represented. So if you said hi A, that looks like this. And the reason that this is so important is because one of the most common errors we see when people program is they added an extra space, or they forgot to use a capital, or they used a capital and they weren't supposed to. So you need to understand that while if I'm talking to you and I type you an email, it doesn't matter if I write all lowercase, hey you, or all uppercase, hey you, or if I include punctuation or not, you and I can interpret those things as having the same meaning. The computer, on the other hand, does not understand that, and you have to be really precise, and this is a source of many errors. Okay, in terms of programming languages, there are tons of different types of programming languages and environments, depending on what you'd like to do. So just a few examples, and this is not exhaustive by any means, but just a few examples include, for instance, if you wanted to create a website, then programming languages you would probably want to learn are maybe HTML, CSS, or JavaScript. I'm sure there are newer ones. These were the ones that were common when I was working on websites. So they are constantly evolving. And I think that's the other thing that we talked briefly about with technology is that it's constantly evolving. Just like you may see your computer have a new operating system update or your software needs to update, these languages are also updating. Also, if you wanted to work in data science, you hear a lot about data science and data analytics now. So there are a few common languages that are used for this because they have the proper, they are built to do those tasks essentially. So Python is one that's used really widely because it has a lot of tools for reading in data, reading in really large amounts of data, and then also analyzing the data. R is another one, which is really a statistical language, but you program to some degree with it, where you just give it commands and it does what you've told it to do. There's also other types of data analysis and signal processing. So like Bash or Linux is like a native terminal. MATLAB is a whole programming environment. And then if you wanted to create your own software, you might use, for instance, C++ or Visual Basic or Java or any number of packages. So these, like I said, are just a few examples to give you an idea of how vast this universe of programming can be. And in each of these, it converts letters and strings of letters, which are essentially words or commands to the computer, into binary strings for the computer. But each one has different commands and each one has different syntax, like we said. So if you said to yourself, I'm going to learn programming today, you might want to think about what language would you like to start with? It's kind of like if you said, I'm going to learn a human language today. Which language would you want to start with? Well, you might say it depends on where you are, what the people around you are speaking, and what's the most functional language for you to learn, right? So similarly for computer programming, you really want to identify what you want to do first and then find the language that's best suited for that. Because each language has a limited number of commands and libraries, which are essentially like people have written lots of commands together to do specific tasks, each language will have what we call different functionalities. So like I just said, some of them will be really great for specifically doing things on the internet. Others will be really great at reading and writing and moving around files on a computer. There's all different types of functionalities. But in this course, we're going to teach you just the very basics of Python because, one, I think it's a relatively intuitive language that is pretty popular, and it also is very versatile, and it's used for a lot of things. So Python is used for data analysis. It's also used for app development. It's also used, you can even use it for game development if you want, and the syntax in the language is pretty easy to learn. Okay. There are some common principles when it comes to programming. So like I said, each language has its own syntax and commands, but the concepts are generally the same. So it's kind of like, in any foreign language class you take, you will learn to say, I'm hungry. Where is the bathroom? Where is I think a common one used to be, where is the library? But maybe that's less common now. So you'll learn how to do the same commands, but across different languages, and they'll just be said differently or typed to the computer differently. Like I said before, when we were talking about binary, every single digit matters. So spaces, capitalization, etc., are all really important because each of those is encoded by a different sequence of zeros and ones, and the computer will get very confused and give you errors if you have the wrong one. But one fundamental truth is that learning the basics of one language typically allows you to learn other languages more easily. So that's also why we start with Python here, because it's a little bit more straightforward. If you learn it in Python and then you later wanted to learn Java or MATLAB or something else, you would have a general idea of inputs and outputs with the computer and how it works. Another thing to talk about just briefly, and like I said, if you're really interested in any of these, you can do a deep dive on the internet to find out more. But there is a difference between what we call command line programming versus GUI-based programming. So command line interfaces are things like what you see here. This is my native terminal on my computer. And essentially, I can type a command into this terminal, and I'll show you this kind of later. But I can type a command, and the computer will do something. So this is how I directly communicate with the computer. That said, and there are different ways based on your operating system. So if you are on a Mac, you would use a terminal like this. If you're on Windows, at the Start button, you can click the command, or you can type in CMD for a command prompt, and it will bring up a similar looking window where you can type commands directly to the computer. Programmers typically will use a command line interface. However, there are a lot of what we call graphical user interfaces. And so these are essentially visual representations of commands, and it makes it a little bit easier for people that aren't doing like hardcore programming to be able to interface with a programming language and environment. So this is like one example, for instance, where you see icons and there's buttons you can click. Almost every software program that you and I would use tends to be a GUI-based or graphic user interface program, because that's how we as humans interact with machines the best, and it's optimal for us. I did just want to say that, though, because for most programming languages, you would use a command line interface for the maximal flexibility. But there are also GUI-based systems that will make it a little bit easier to get started. And these are also often called interactive development environments, or IDEs. So an IDE typically for a language will have an editor where we type the code to the computer, along with tools for debugging the code, buttons, ways to visualize the variables that we have that are active, and a way to see the output. A lot of this, if it's starting to feel a little bit overwhelming, a lot of it I think will become more clear once I actually open up Jupyter Notebook and Anaconda and kind of show you a little bit around. But I wanted to give you this background first. So For Python, since that's what we're going to be using, there are a few different IDEs that are popular, but there's probably, I would guess, 100. And there's so many because people have different preferences when they program. So some people like the way that Spider, the layout is, and other people like the way that certain commands are highlighted in different colors. Or they just use different ones because that's what they are familiar with. So there's lots of different IDEs that you could use to program. I will also show you Spider today, just because it's also part of the Anaconda environment. And then I also have some links if you wanted to see a little more. And then there's also a link to an online Python compiler, which is one where you don't have to download anything and you could type commands and kind of see what they look like if you wanted to play around with Python a little bit first. Okay, so in this class, like I said, we're going to use a little bit of both. We're going to download a computer package called Anaconda, which we chose because it has both GUI and command line options, and it can be used both on Windows and Macs, and Linux if anyone has a Linux system here. Although I kind of feel like if you had a Linux system that you use as your primary system, this class might be a little bit too easy for you. And then within Anaconda, we're going to use some of the subprograms it has. So we're going to use one called Jupyter Notebook, which will allow us to type Python commands and see the output right away. And I've chosen this because I think it's the easiest for initial learning and debugging. And then in this class, the language that we're going to use is Python, and specifically Python 3.0 or 3 point something, but Python 3. I make that distinction because, like I said, tech is always evolving and languages are evolving too. So for the longest time, Python 2 was the most popular. Python 2.7 was probably the most stable version that most developers and programmers used. And then now most people have kind of migrated over to Python 3. And so that's what you'll be learning in. Okay, and then just a quick note on debugging. The only feedback, so unlike a human, if you said something wrong, they could just say you did that wrong and then tell you why or what you did wrong. With a computer, when you're talking to it, the only feedback you will get when you try to execute a command is an error, or it will execute your command successfully. Those are really the two things that happen. Debugging is essentially where we fix errors or unexpected results, and we try to figure out where we went wrong. This is a huge part of programming. I would say most of our time is spent, we spend a little bit of time writing code, and then most of the time debugging it and making it correct. So ideally you debug as you go so you can identify the mistakes early on versus after you've written 1,000 lines of code and then you have to go back and search for where the mistake was, because sometimes the errors you get from the computer are not that helpful and it really takes a lot of problem solving to trace it back. But it is problem solving, and this is one of the things we can do together in class if you end up with errors. I want to put this out there now though, because this is the most frustrating part of programming, but it also is a foundational part of programming. You cannot program without debugging, no matter how proficient you are. You will never get to that point. Everybody debugs. So I just want you to know that it's normal to get errors. Try not to get too frustrated. Just take it as part of this process. And everybody has to debug. And part of what we'll do with this class too, and these like recorded sessions, is I plan, for instance, to do everything live without a lot of like heavy editing, so you can see when I have to debug too. And I think when I was learning how to program, I just watched other people write code and do the things that they were trying to do. And I saw them run into errors that I had run into, and it made me feel better because it made me understand like, oh, everybody makes these mistakes. Everybody has errors and has to fix them. Okay, so as we are about to get started, I want to talk briefly about your file structure. So like I said, every character has a different binary representation. So spaces count, underscores count, etc. So in our programming and in our class in general, we try not to use spaces because those get interpreted by computers slightly differently sometimes, and they are very, very tricky. So we like to stick to letters, numbers, and underscores when we are naming files and naming things. What I'd like you to do is make sure that in your home folder or your main folder, So on a Windows machine, this will be like your C drive. On a Mac, it will be like whatever your username is. You should make a folder called OT699 with OT in caps and no spaces. And then in there, you should make another folder called week 1, where week W is capitalized and there's no spaces. And then you also should download our OT699 underscore week 1.ipynb file, which is Python notebook file from Blackboard, and put it in here. So this is what it should look like so that you can open it. It will all look the same for you as it does for me. If you have any questions about this, feel free to reach out and email so that we can at least be on the same page with getting this started. All right, the next part is we're going to install the software. So like I said, I'm going to do this live with you. I actually had Anaconda on my system, but I deleted it and uninstalled it so that I could do it again with all of you and show you exactly what this whole process looks like. We'll install Anaconda. We'll open the GUI, which is Anaconda Navigator, and then we will click on Jupyter Notebook. And then within Jupyter Notebook, we will select this OT699 file that we downloaded into our computer, and then we will start typing a few basic commands. So, all right, I'm going to finish this video. In the next video, I will show you the complete download, installation. All right, so now I'm going to do a live demonstration where we're going to download Anaconda, set everything up, install it, and start typing our first lines of code. So I'm a little nervous, I'll confess to you, because I have not done this live before, or quote unquote live. I'm going to try not to have to edit the video so that you can see everything as I go through it. The goal here is for you to also be able to download and do all of these steps along with me. You can either do them as I do them, or you could watch this video first and then do them, whatever you're more comfortable with. Okay, so I'm going to share my screen. All right. So I'm just going to type Anaconda Python. Oops, Python. Anyways, it understood. So I'm going to click this. So this is Anaconda. It's a computer program that provides a distribution of Python. If you don't land on this page, you can go to Products and Individual Edition. Okay. And we go down to Download. And then it gives me a list of installers. So in this case, I am working on a Mac computer, but obviously if you're on Windows, you would download Windows, and if on Linux, then Linux. In either case, you're going to want to download the 64-bit graphical installer. So I'm going to download this one with Python 3.8. All right, and now we're just waiting for it to download. If you're curious about Anaconda, there is this tutorial. So you could open it. Oh, I have to register. What is Anaconda nucleus? Okay. Anyways, you probably don't need that because I'm going to walk you through all these things. But if you wanted to and you wanted a little more, you could register for this. I don't actually know what Anaconda nucleus is, but you can register for it and test it out. Okay. I'm going to close that. There is also documentation. Hopefully this does not require a login. Oh, yeah. So getting started, new to navigator, et cetera, et cetera. Anaconda can take you on a very deep dive, so it's not necessary to go down all of that. I hopefully will show you everything that you need to know. But if not, and you want to know more, you can use those. Okay, so I'm just going to open the package. I'm going to continue, agree, and install for me only. Install. The only time that you should need the other ones or to install like on disk is if you are running some sort of like computer that has multiple users. I would guess that's probably nobody. All right, so we're installing. So one thing to note is how quick this installation is. It's not super, super fast, but like I will be talking about later, and like I said before, each language and distribution comes with a variety of packages and kind of like pre-written code so that you can do certain things with it. And if Anaconda included every single Python library and package so that you could do everything Python could do, this download would take hours probably, or maybe not even be downloadable because it would be so large. As it is, it still takes a little bit of time because there are a lot of complex parts to it. But yeah, so that's why later on we'll talk about importing libraries. I think in next week's class, we'll talk about libraries and packages, installing additional packages and libraries, and then importing them into the Python environment. I guess during this time you could get some tea or coffee or water. All right. Now PyCharm IDE, working with Python and Jupyter Notebooks is a breeze, designed to be used with this. Okay, I think that's just an ad. All right, we're good. So now we have it. Close, move to trash. Okay, and if you're on a Windows computer, that process might have looked slightly different, but hopefully it will run you through the same types of steps. Okay, so the next thing I'm going to do is I want to open it. So at least on mine, I think on a Windows computer, you'll go to the start and type this in. On a Mac, you'll go up here to the spotlight and I type Anaconda 3. Oops, it's up here. And in this folder, you'll see something called Anaconda Navigator. I could also just have, oh, where did it install it? Oh, interesting. Okay. It's not where I thought it would have been installed. Usually it would get installed into applications. Oh, here's Anaconda Navigator. Okay, so you could just go into applications and go to Anaconda Navigator. I think you can also from here, if you type in, no, I guess not. Can I do that? No. All right, anyways, double click Anaconda Navigator, whether you're getting it from applications to Anaconda Navigator or from your user folder to Anaconda Navigator. So Anaconda Navigator is what we call a GUI-based system. So as you can see, these are all different little icons that represent different programs that you could use. I will show you in a second Spider at the end. We are going to use Jupyter Notebook. So we're going to just click Launch. It's a little bit slow. There's the color wheel of waiting. Let's see what happens. This is a terminal window that's come up. That's basically telling us what's happening. And then Jupyter Notebook opens in your web browser. So hopefully you have Google Chrome. If you don't, I would really recommend that you install it because it works really well with Jupyter Notebook. But essentially, just to review what I just did is I clicked Launch on Jupyter Notebook and it opened in my web browser this kind of homepage. And this is a file browser. That file browser actually looks quite a bit like my own file browser. So if I go to SLU, you'll see the same folders, applications, classes, data. It's all mirrored here. So like I asked before in the last lecture, you want to have a folder called OT699 with no spaces, and then a folder called week 1, and then something called OT week 1 IPy notebook. So, okay. So actually, I'm probably going to do something a little different and just have you make a new one. So let's click this folder and click week 1. Now we're in here. I actually forgot what I put on this notebook. Oh, nothing. Okay. So in this notebook, what we're going to do, this is, let me orient you just a little bit. So when you first open Jupyter Notebook, it kind of looks like a general file browser. So you can see your file pathway up here. That's your home directory or root directory. This is the folder that you made for OT699. This is week 1. These 2 little dots here mean go back up 1 level. So this would take us back to the week 1 folder. And if we went up a level again, it would take us back to this home directory. So we click back on the OT699 and then click back on week 1 and then click on the OT699 week 1 Jupyter Notebook. Okay, so this is the notebook that we're working with. I did take a pause there so that I can make sure I lined up a bunch of fun commands that we can try out together. So the very first one, your very first command is a very stereotypical one. It's called hello world. This is kind of like the geeky thing that everybody knows that we always do in computer programming, but it's your first command to the computer. So type the word print, put a parentheses, and it'll autocomplete the other side of it. Same thing if you do quotes, it'll autocomplete it, and then type hello world. Okay, so this is your command, and you're going to run it. So you can either click this run button here, and it's going to type hello world back to you. You can also do, in order to run a command, a shortcut is to press Shift and Enter together. So I could also say hello world, oops, this is Lee. Then I press Shift and Enter, and it will run that command. Okay. The other thing, I mean, there's a lot of things you can do, but congratulations on your very first command. And then other things that you can do, well, there's a lot. So for instance, we can do something called create a variable. We'll talk about this a little more in depth next week too, but for now you can just follow along with me because it's kind of fun. So you could say, we can have a variable that we call my name, and we're going to set it equal to, and then this is where you would type your name. I put Lee because that's mine, but you could put whatever your name is. Okay, run. So nothing happens because we didn't ask the computer to output anything back to us. We just said to assign this variable to this value, which is your name. Then you can say print hello world, this is, and a space, and put plus, and you're going to put my name here. And it should say hello world, this is, and then print your name. So let's run this cell, and it does. So that's nice. If you want to add punctuation, you can do the same thing. You can actually go back to this cell. You can make a new cell or go back to this one and just edit it. And let's say I want to do an exclamation point, and I rerun it, and now it says hello world, this is Lee with an exclamation point. Other things that I can do, like I said, there's millions, maybe trillions of commands that you can do, but these are a few of the ones that are built in. So like I could say, I could use the command len, L-E-N, which stands for length. So this command, when given a string, will tell you how long or how many characters are in the string. So let's say I put how many characters are in this sentence. Make a note that whenever you're typing text, like letters, you want to use quotation marks because it lets the computer know that these are letters. And this is a type of data type. So there's 41. And that's probably faster than it would have gone if I had counted it. If you want to be sure, you can just try it with a shorter word like this. And then you could just say, for instance, hi, the length should be 2. and it is. Other things that you can do, you could, for instance, splice out words. So let's say you do print hello, but now let's say you just want to print the first 2 letters of hello. So you can do what's called brackets, and you can slice out essentially just from 0:2. And if you run this, it'll just give you HE. So you can play around with this. I encourage you to play around with these different examples, try different things. You can also do some little tricks like capitalize things. So let's say I put a new variable called name lower. So it's going to be my name in lowercase. So lowercase LEI. And I'm going to click run, or again, press shift enter. And if I say print name lower, oops, click run, it'll say what the variable that I gave it. But then if I say name lower dot capitalize, capitalize is a command, capitalize is a command that should make my name uppercase. So let's run that, and it does. So it creates a capital word. And you might wonder, why would I ever need this? Well, there are cases where you're trying to go through files and you want to rename everything. All the names for whatever reason are in lowercase, and you want them all to have to be capitalized. So instead of manually changing a list of 100 names, you could run this function on that list of names, and it would do it for you in less than a second. So these are some little tricks. You can also use what's called lists, and to be honest, like if we're doing a real formal programming class, we would get into data types, and next week we will talk actually a little bit about data types, but then also about different like types of constructs. But let's just say we can just know that you can do things like say, I want to make a list of all these fruits, and the syntax here is to use brackets, square brackets, and inside there I'm going to list different fruits. So let's say apples, grapes, bananas, mangoes. You can also add whatever else you want. But let's say I do this. Again, just like that one variable where I said lower, name lower equals Lee, this time I said fruits equals all of these different things. And with a list, there's different functions that you can use to help you manipulate it. So for instance, I can do fruits.sort, and sort is a function that should alphabetize that list. So if I say print fruits now, it's now in alphabetical order. So apples, bananas, grapes, and mangoes. Okay. Like I said, this is a really brief overview just to get you familiar with programming, writing commands, and starting to think about things that the computer can do. We can also do math. Math is a built-in function in Python. So for instance, you can do addition. You can also do subtraction. You can do division. That's with a backward slash. I'm obviously just typing random numbers. You could type whatever you want. And you can even do, I think this is the command for square roots. Oh, so this is our first error. So it says the name error, square root is not defined. That means that this is not actually a command. So actually what I would do if I wanted to know this is I would just Google Python square root command. And it should be SQRT with a number. So what did I put? Let's see if it has to be part of a thing. Oh, all right. So square root apparently is not one of the built-in commands, but it is part of the math module. So it's something that, for instance, next week, we're going to talk about importing libraries, importing modules so you could do more functions. So square root is a command that is not currently known, but if we import the math module, it will be. If that's confusing to you, don't worry about it. It just means that it's not part of our defined list of commands right now. And next week, we'll learn about how to define new commands and import libraries. Okay, so no square root for now. I think one of the commands that is part of this is one called round. So let's say we wanted this value, but we wanted it to be rounded up or down to the nearest integer. So we could put that in there, and it gives us 0 because it was 0.01. To take a simpler example, if you wanted to round 5, 6, it would round up to 2. But if you had a smaller number, it would round down to 1. So you can do things like this. It has a bunch of built-in math functionalities. Let's see. At this point, if you haven't encountered any errors, you're doing great, other than the one that I just showed you. But there are some times where you'll have errors. So let's go back up to here and let's pick this one. I'm just going to copy it and bring it down so this is all clean. Let's say print hello world. This is Lee. And let's say I forgot the second quotation mark and I tried to run it. So it would give you an error. This error is a syntax error, and it says end of line while scanning string literal. And it has this little hat that shows me there is a problem somewhere here. Then I would review it and I'd say, oh, I forgot this quotation mark. Note, again, whenever you press quotations in Python, it'll autocomplete to give you 2. So you backspace, so you just have 1. It does give you some color coding. So this parentheses is green, if it's correct. But if, for instance, like the strings are red, so if there is a lack of a quotation here, you'll see that this last parentheses is still red instead of green. Okay, so if you click it now it's correct. Okay, and then just to orient you a little more to Jupyter Notebook itself, in the notebook, you have a lot of different options. I mean, we're really just going to use it like this so that you can type some lines of commands and see the output really quickly. But you can do things like delete cells. Let's say like when you click on a cell to type and interact with it, it'll be green. You can also press escape, and this makes it so that it's not in an interactive mode. At this case, if you wanted to delete the cell, you could press D, the D button twice, and it'll delete it. When it's blue, if you want to add another cell, you just press A and it'll add one. A. What else? I could run all of these lines at once if I wanted. So I could go to kernel and restart and run all. And that would clear all the outputs that you see, and then it'll rerun them all. It happens super fast because these commands are really lightweight and quick to run, but it's just some examples of what you can do. And then if we go back here, and let's say in week 1 you wanted to create a new file, you could go to new, notebook, Python 3, and it would create a new one. So up here you would type your title, so you could call it my new notebook. Remember, we tried to avoid having spaces. Rename. And then in this one I would print, this is my new notebook. And then I would run it. Okay. So that's about it. That's about as far as we're going to go with Jupyter today. You can look up different commands. What I really encourage you to do is with these commands, play around with them. So you can like add other things to kind of see how it changes. You can also try Googling things. So like you could Google like basic Python, Python commands to start with. Maybe like a getting started one or Python for beginners. So you can kind of interact with these types of things and see what the exercise is. So like I said, the most common first command is hello world. But you can try out a bunch of different things. You can make new files, etc. So just get familiar with Jupyter and also with Python. And then the last thing that I wanted to show you in Anaconda is in the Navigator. So go back to Anaconda Navigator. And this is Spider. So we're going to click on Spider, launch. You'll also use PyQt later for the app course, I think. So that's why we had you start with Anaconda, because it's the whole built-in environment with lots of different things that you can use. Spider is going to open, it's kind of like a separate program that launches from this navigator. So this is another type of environment. I'm going to say, okay, I want access to all my folders, fine. I don't want to check for updates on startup. Can use Kite for better, more accurate code completions, such as NumPy, Matplotlib, and Pandas. If I was going to use Spider more often, I would probably install it, but at the moment, I'm just going to dismiss it and maybe do it later. Okay, so this is maybe what you might think of as a more standard programming environment. So this is its own program. This is an IDE, like we talked about, or interactive development environment. On the left is the editor, which is where you would type the code. Down here is the console, so this is where the output happens. And then there's a lot of things you can do. You can visualize your plots, you can visualize your files. So as you see, it's a little bit more interactive, and this is really great when you're going to write more code, for instance. So let's try here. We have a file right now called temp.py, and we will try print hello world. And as you'll see in Spider and in different interactive environments, they will do things to help you. You can change your preferences if you want, for instance. But like when I was typing print, it gave me some examples of what I could do. So if I click run up here for print, you'll see the output out here. What's this? Oh, run settings. Execute in current console. Yes. Directory of the file. That's fine. Okay, run. Okay, so it ran the file and it gave me hello world. So you could take all of the commands that we did over in the Jupyter notebook over here. Let's say we want this one. And you can just put them one after another. We can do them like this. Let's put a few together. Okay. All right, so if we run it, the difference is that with Jupyter Notebook, we were just typing single commands and getting single outputs. So this is similar to the editor, but just with one line. And this is similar to the console or the output window for each single line of code. In this type of editor, you would type all your lines of code and then run them all at once. So we could type it like this. And as you see, it says hello world, this is Lee. And then it executes this command and it says hello, this is Lee as well. Okay, so you can also play around with Spider if you want. Most developers will use something like this because it is a more classic environment and you're usually writing hundreds of lines of code. So at that level, you want all your lines of code to be contiguous and run together. We use Jupyter Notebook. I use it a lot when I'm actually writing code, a new script for the first time, and I want to debug it as I go. That way I can put, and you can put multiple lines into one cell like this, and it will give you the link for both of them. But the difference is that it lets me debug faster and easier. And then once I'm done with it, I can also do file, download as, and then download as a .py file. So remember, this file is a IPyNB, which stands for Python Notebook. But files that you would read into this, into Spider, are going to be .py files. So you could download this as a .py file. I'm going to put it back into my class one. Week one. Save. All right, and now I have this. And in this Spider ID, I'm going to open file. I'm going to go to 2691 pi. And this is going to all be here. So I could actually run everything that we did in Jupyter together by clicking this button, and you would see all of our different outputs that we had. Some of these don't print out to the screen, like a lot of the math ones, because these were actually just outputs that we didn't specify we wanted to print to the console. That part may be a little confusing. We can talk about it in the class though. But feel free to play around with it. You'll also notice these are what is called comments. So putting a hash in front of something makes it into a comment so it doesn't get executed by the computer. It's more a note for yourself. So this is a note just for me. But it won't change anything about what's run. So as you see, it doesn't show up when you execute the commands. Okay, I think that's probably a good place to stop. We've given you a little bit to get your hands wet with. Hopefully you enjoyed it and you can tell people that you are programming now. Well, you're writing lines of code at least. Okay, so I think with that, let us know if you have questions. You can send me an email if you're going through this and you're getting stuck. We will go through everything together in the live session, and then I'll also have time after that for office hours if anyone has questions. All right, thanks a lot.